Viking life-saving equipment produce highly flexible, combined work and anti-exposure suits that allow users to stay safe and mobile in even the harshest of maritime conditions.
Viking was established in 1960 producing primarily life rafts, but since the early 80s we've also been producing protective equipment, meaning immersion suits, life jackets and fire suits. Currently we're about 2,000 staff worldwide with offices pretty much all over the globe.
The production of one of these anti-exposure suits starts with design. This will begin with a brainstorming process that will then go on to a mood board. Designers and engineers will look at three main points when designing their immersion suit. First and foremost is safety, next is functionality, comfort and fit, and then finally the aesthetics of the suit. Once the mood board has been discussed, the designers will then construct the suit digitally, using computer-aided design or CAD software. This allows them to look at every inch of the suit in depth and make alterations where needed, without having to make a single stitch. With the design complete, the information from the design software is inputted into a CNC machine that will then cut out all of the relevant patterns and components needed to form the finished anti-exposure suit.
Having a full accuracy in the cutting ensures a consistency and a quality in the overall product. So getting started right ensures that you get the right flow through the entire production.
The process is set up in such a way that it keeps fabric wasted to an absolute minimum. Working a bit like a reverse jigsaw puzzle, the machine will choose exactly where to cut out each separate component to maximise the material used. The cutting table itself is also quite important. This table contains tiny holes. Under these holes is a vacuum, sucking down on the fabric so that it stays in place and can't move when cutting is underway. Imagine an air hockey table that pulls instead of pushing out air, and that's pretty much what this vacuum table is. With all of the components cut to shape, it's time to begin the sewing process. Here the anti-exposure suits all come together as one, with many sewers all working away simultaneously to bring it together. Although they may not look it, these sewing machines are a bit different to the everyday sewing machine you might find at home. They can stitch at exceptional speeds with great precision, making sure that every seam is exactly right. That's the sewing finished. It's time now to work on the seams of the suits to ensure that it is completely watertight. A combination of heat, glue and pressure ensure that the seams are very firmly sealed shut. These highly trained operators will constantly check the seams as they work, as accuracy here is vital to the safety of the anti-exposure suit's end user. These special seam sealing machines are highly accurate, and the operators know exactly the right speed to operate the machine so that it seals perfectly.
One could argue the more features you have on the suit, the more sewing and the more seam sealing, but it's very, very key that you master the seam sealing to make sure that you get a high quality product and a durable product down the road.
The customizable elements such as boots and collars are then mounted to the anti-exposure suit. This is all glued and sealed together by hand, with just as much care and attention as with every other element of the suit. Now that we have everything in place and sealed, this anti-exposure suit needs testing. Every single suit is tested before dispatch. The suits must be turned inside out and then filled with water so that any leaks can be spotted. An operator will check every inch of the suit, front to back, to ensure its safety.
Every single suit that comes through production or every single suit that comes through our service network will be serviced in the exact same way, ensuring 100% compliance and 100% integrity of the product before it meets the end user in a critical situation.
These tested suits can then be hung and placed into this huge dryer for 2 hours. As well as this, the bladder of the suit that works much like a life jacket, giving buoyancy to its wearer, is also tested. Here the bladders are inflated to 400 millibars of pressure for 1 hour. After this hour, another measurement is taken to ensure that the pressure is still the same. This is then repeated with a slightly lower pressure. If both tests are passed, they're good to go. Once dry, the suit is packed up and sent around the world, ready to be called into action when needed, and save lives in the process.
This type of product is being used pretty much from Navy, across oil and gas industries, to the fast rescue boat operators on a cruise line, to the local fishermen. So in that regards, we try to take a lot of input from different industries to make sure we find a product that would fit the end users in all these different segments.
Anti-exposure suits. Now they really are a wicked invention. Modern-day life rafts really have come a long way since the cumbersome boats of yesteryear, and we're going to discover how the perfect fold can increase your chances of survival. At their facilities in Denmark, Viking life-saving equipment produce some of the most modern and widely used rafts today.
We have produced a lot of life raft over the years since 1960. We know our life rafts have been used in emergencies. We are in contact with people who have been rescued by our products and are of course very happy that in the situation where they needed it the most, they had a product that worked to the fullest and who saved their life.
The Viking Rescue Pro Life Raft is an efficient last resort means of evacuation, intended for use by people on board yachts in the case of an emergency caused by fire or sinking. Once launched and inflated, the life raft provides good shelter, protection and all the necessary survival equipment to keep evacuees alive until rescue arrives.
Everyone who works with the life raft know that what they do can eventually mean that it will be saving somebody else's life.
The materials used for a modern-day life raft must be of the highest standard to ensure the safety of passengers in an emergency. Because of this, a life raft's production begins with testing the raw materials of natural rubber and canvas before they can be used. A tensile testing machine is used to test the strength of the materials by stretching it with great pressure. This then records the pressures used, and with this data, we can see at what point the materials will break and how much they are able to stretch. With the materials now tested, the next stage is design. Using computer-aided design or CAD software, raft engineers can hone their designs ready to be put in production. The designers must include key features, including self-righting abilities and 2 large entry points, meaning that it can be boarded within seconds. From here, the designs are sent to a cutting machine. The materials that have been tested are laid out onto a large cutting table, where the machine will then cut it to the exact specifications of the design. Another clever little trick by the machine is to lay out and cut all of the segments of the raft in the most efficient manner possible, keeping wastage to a minimum. Once the materials have been cut to shape and size, the canopy of the life raft is sewn together, using traditional sewing machine techniques. This very hands-on approach means that each operator sewing is able to consistently check their work and the materials throughout, making it extremely accurate and minimizing any faults. Of course, this little raft is going to need to stay afloat. The next stage of production is to glue together the tubular modules of the life raft that will inflate and give the raft its all-important buoyancy. Highly trained technicians precisely glue each piece together using an extremely high-strength, water-resistant adhesive. Now that the tubular modules have been glued firmly together, it is vital that they are tested for any leakages that may prove fatal if and when the life raft is ever needed. The modules are inflated with double the required working pressure. They are then left for half an hour, where the inflated modules can be analysed for any air leaks. Because double the pressure is used, the technicians can be confident that if there are no leakages at this point, the life raft will be stable when called into action. Our life raft is really coming together now. We're at the assembly stage, where the bottom, ballast bags and canopy can be assembled onto the inflated rubber modules. Again, this process relies on manual craftsmanship and precision. Once the raft has finally been assembled, the all-important emergency kit of the life raft is fitted. The contents of this kit include flashlights, batteries, parachute rocket signals, drinking water, first aid kits, instructions for use, and many more vital components that will give those passengers in need their best chance of survival. With the life raft complete, it is time for it to be packaged. The life raft, complete with emergency kit, is compressed and packed into a compact and sturdy fiberglass container. It is vital that the life raft is creased, folded and rolled in exactly the right way so that it's guaranteed to deploy properly if needed. It's amazing how compact the life raft can be made so that it takes up minimal space on deck. This means that multiple life rafts can be stored on ships so that every passenger has a chance in the event of an emergency. Once the life raft is finished, it is time to be tested on the open waters.
I think that's something to be proud of every day when you go to work, that what we do can save lives.
With its ability to inflate almost instantly and be stored without taking up too much space, this modern life raft truly is a wicked Life-saving invention.